Okay, so let's finish this the proof of the Bloch theorem. So last time we mentioned that these uh, so last time we said that the image of the unit disk under the mapping F contains a disk of radius r3/6m, right? So so last time do that. Contains a disk of radius r square over 6m. Okay, so this is the result. Yeah, we proved last time. Okay, so so remember that we made some assumption about this f at the beginning. So we are assuming that this f is analytic over a closed unit disk. So now we want to eliminate this assumption. So to eliminate the assumption so we actually we employ a routine approximation argument as follows. Okay. So first we let this f epsilon z so to be equal to f of 1 minus epsilon of z over 1 minus epsilon, where this epsilon is between 0 less than epsilon less than 1. Okay. So we let f to be Yeah. Okay. Yeah, we got F. Then, this epsilon z is analytic in the closed unit disk and satisfies. Yeah. So yeah, why is it analytic? Analytic in the closed unit disk and satisfies. Oh, okay. So because this F is yeah. So yeah, this as Z is. So basically, you can think of this what they call yeah. So it's not only in with this. Okay. So close unit disk. Okay. So why this apps this is analytic in the closed unit. So okay. So basically yeah. So basically you can think of you. Okay. So basically you take the Z to be any in the closed disk, and then this and this F. Okay, yeah. So it's so okay, yeah. So basically. Okay, so it is analytic, and then satisfies yeah, satisfies this at time answer 0 is equal to 1. So why okay, f prime epsilon 0 is equal to 1, so that the result above is wait, what is the result? Applicable way to this f epsilon z. Okay. Yeah. Oh, okay. So then it follows that the image of the unit disk under the mapping f of 1 minus epsilon z contains this of radius 1 minus epsilon r square over 6m. Okay. Okay. Yeah. So now let epsilon goes to 0. Okay. So basically the idea is that we know that each of these f 1 minus epsilon z contains a disk of radius 1 minus epsilon r square over 6m, and then okay, so and then with that epsilon goes to 0, like that oh. Yeah, so when that epsilon goes to 0, then yeah. So if you let me see. So if you let's see. Okay, so let's check it from here. So f prime epsilon. So if you take the derivative, right? So yeah. So and then when you evaluate at 0, it will be. So when you take the derivative. So by the complex chain rule, it will be f of z, right? So yeah. So when you evaluate at 0, it will be just f at 0, and then what is this f at 0? So this f at 0 is what? Wait, so how did you define? Okay. Yeah. So f, we know that this f prime 0 equal to 1, right? So wait. I forgot. I think there should be a prime here, right? So yeah. Okay. So yeah. So now it's equal to f prime 0 equal to 1. Okay. So this is a check. Okay. So now what about yeah, so why the result, okay, f prime 0 equal to 1. Yeah, so the result of applicable to f of z. So then what else we need to check? Analytic in a closed unit disk. Yeah, okay, so why this one is analytic in closed unit disk? So basically the idea is that if you take any, so for z in this closed unit disk, right? So then yeah, so in the pre-result, we assume that the thing holds for this any function that is analytic of the closed disk, right? So this function is analytic in the closed disk. So yeah, so then it satisfies the above condition, right? So okay, so why this is analytic in the closed disk? So if we drop the condition that fz is analytic on a closed disk, right? So then this function, so let's see, okay, so yeah, so this function basically I think is like, so if you take any, let's see, why is analytic in the closed disk? Oh, so analytic in a closed disk means that it is analytic. It can be extended to like a neighborhood of the closed unit disk, right? So why is that true? So I want to say that since this f epsilon z is being defined over to be equal to this f of this 1 minus epsilon z over 1 minus epsilon. So what happened to this z? So so we know that this f is analytic from so okay, so we know that it f is analytic in this disk, right? So why this is analytic? So basically if we take any z, right? So if you take any z, then it is, oh, okay. So basically you can, yeah, basically I think the idea is that you can take a bigger, like bigger neighborhood that is slightly bigger than this disk, that this f epsilon z is being defined as maybe 1 over 1 minus epsilon. Let's see, I think that will work, right? Let's see, if you take any, maybe I need something smaller, but yeah, so let's see. So if I take any, yes, so if I take any z in this disk centered at 0 with radius 1 over 1 minus epsilon. So this implies what? So this implies this, let's see whether, okay, so this f, I want to say that, okay, so I want to say that this f epsilon z is actually analytic over this region, right? So therefore it is, so why is f epsilon z is analytic over this region? So so basically if you take f epsilon z for z, which is equal to is f of 1 minus epsilon z. Okay, so this since this we know that this modulus of z is less than 1 minus 1 over 1 minus epsilon, right? So therefore the modulus of 1 minus epsilon z is less than what? Is less than modulus of 1 minus epsilon, which is still 1 minus epsilon, times one minus epsilon. Okay, so less than 1. Okay, so we are good. Okay. So so this is like this is that. Okay. So so this is, we know that this modulus is less than 1. So therefore, and we wait. Okay. So we know that it's been well defined, right? Because we are assuming that f is analytic from the unit disk. So any z in this equals unit disk, it is well defined, right? Okay, so now why it is analytic? Because it is a composition of analytic functions, right? So it is analytic. So therefore, it is analytic in the closed disk because it is actually analytic within a bigger band, right? Okay. So then satisfies true. Okay. So so by the argument above, then applies to that. Then it follows that the image of the closed unit disk under the mapping f times 1 minus epsilon z contains a disk of radius 1 minus epsilon times. So why that is true? So let's see. So follows that the image of the unit disk under the mapping contains a disk of radius 1 minus epsilon. Okay, so let's see. The image of the unit disk under the mapping. Why is it true? Okay, so because remember so I think why is it true? So by the lemma we proved before, right? So so by the lemma we proved before. What is the lemma we proved? We have proved that we have proved what? Okay, so we have by the things we proved this okay, so let's see. So let's verify. So by the things we have proved, right? So this image of what's the thing that we proved? So we have proved that this the image of the unit disk under the mapping F also okay. So yeah, so this is what we proved, right? So the image of the unit disk under the mapping F contains a disk of radius r squared over 6m. Okay, so this is what we proved. So okay, so basically, okay, so let's see, contains a disk. So let's see, there exists a, let's see, the Z naught in this F atom D, such that, what's it called? Like, disk of radius r squared over 6m, right? So such that this F atom D, oh, sorry, so this D of center at Z naught of radius r squared over 6m. Okay, so this is the disk of radius r squared over 6m is contained. It's contained in the image, right? Okay. All right. So so this is by the pre-result. Okay. So this is by the pre-result. So why it is contained? Okay. Oh, okay, okay. So you see that this F, right? So it follows that the image of the unit disk under the mapping F of, okay. So okay, so okay, so now for any, let's see, okay, so let's see, so let's see, for any, so if I take any Z, okay, so I want to show that, okay, so let's see, what do I want to show? Wait, contain the disk of radius. Okay, maybe let's just start, see where it goes. So if I pick any Z from, let's say this disk, right? Maybe let's just start with here. Okay, so let's pick this Z in this disk, right? So disk of center at Z naught of radius 1 minus epsilon r squared over 6m. Okay. So so I know that this Z minus Z naught, right? So it is less than like 1 minus epsilon r squared over 6m. Okay. So okay, so therefore we know that this Z minus Z naught divided by 1 minus epsilon. Okay. So it is less than that, right? So so therefore I know that wait, so what do I want to say? I want to say that this one is actually contained in that disk, right? So wait. Okay, okay. Wait. What do I want to say? Okay, so this one is that this is equal to okay, so when you divide by 1 minus epsilon, so when you divide by, oh, you are actually making it larger, right? You are actually making it larger. So yeah, that should be true, right? Yeah, yeah. So, but why? In order to show that y is true, so okay. So okay. Wait. Wait. So this z is actually in the think this might be true. Okay. So this guy, oh, okay. Yeah, I think this is true, right? So because if you take the D now, yeah, if you take this, yeah, and then you take the modulus, which is the modulo of this guy, which is that. Okay. All right. So, okay. So yeah. So therefore, there is a unique, right? So we forgot to say that there is a unique. So there is a unique, let's say zeta in this what? So let's say that let's say that there is a data in yeah, I think but yeah, sorry, I'm not so sure. So I think universally just implies injectivity, but I see it on Wikipedia. So but I'm not 100% sure. So I think probably it's true. It's a unique, but I think it's unique. Okay. So yeah, maybe I just read it with me, but yeah. So maybe you guys can please you can correct me if I yeah. So this is like zeta in this disk, right? Such that maybe I just say there exists. Okay. There is a zeta in this disk such that f of this zeta is wait, epsilon of this zeta is equal to this z prime, right? So where shall I continue? So okay, let's see. So therefore, okay, so here, okay, so therefore, we know that this, okay, f of 1 minus epsilon zeta over 1 minus epsilon is equal to this z prime, right? So and then z prime is which is equal to this oops, okay, z naught. Oh, okay, so z minus C naught over 1 minus epsilon. Okay. So therefore, what we have is that this f of seems there is some issue, right? So I run into some issue. So okay, so I think the thing is that I think the thing is that you should add one minus epsilon here, right? So gosh, why is it so crucial? So wait. Then so all right. Anyway, so what time do I have? So okay. So I know is that what it should be. So I know that these okay. All right. So I know that this F so there is a shift. Wait. Okay, I know that. So it should be okay. Well, everything is multiplied by epsilon. So everything is multiplied by everything should be shrink accordingly, right? So there should be a disk of